Hello, in this video I will do an IBEW practice exam on algebra and functions. So this will be the most difficult practice test. So let's begin. So on question one, it says consider the following formula: a squared b equals bc plus 3 parenthesis c minus 1.5, and what we got to do is figure out the value b. So we got to find b. And what I would do to find b is I would just plug in the values now and then just isolate b. Okay. So they said that A is 3 and C is 5, so you can definitely do that. So A is 3, so this would be 3 square B, and then it's B times C, so B, I don't know what B is, C is 5, plus 3, and then it's C minus 1.5. C is 5, so you could just replace that. C with 5, it's 5 minus 1.5, okay? And so you get, this is 3 squared, that's 9B, and then 5 times B is 5B. What's 5 minus 1.5? Or you could just leave it as it is and then FOIL out this way, it's fine. So our goal is to solve for B, so what I would do next is right here I would FOIL out this 3, so 3 times 5 is 15. 3 times negative 1.5, so I know you can't use a calculator on this exam, so you need to know how to multiply decimals. So if you recall, this is how you multiply with decimals. 1.5 or negative 1.5 times 3. 5 times 3 is 15, carry the 1. 3 times 1 is 3, carry the 1, that's 4. And then what you do is count the total decimal places. So there's a total of 1 place. So you move it 1 place to the left. So it's going to be negative 4.5. Okay. Okay. And then on the left, it's just 9b. So now what I would do is get all the b's on one side. So I'm going to subtract 5b from both sides. And then 9b minus 5b is 1, 2, 3, 4. 4b. And then over here, what's 15 minus 4.5? But you need to know how to subtract decimals because you can't use a calculator. So 15. So what you have to do is kind of line up the decimals. It's not the same thing as multiplying, right? So line them up. So 15 does have an invisible decimal here, and then minus 4.5. So you see how I lined up the decimals? And I put the smaller number on the bottom. So what's 10 minus 5? 5. Carry the 1. This is 4. This is 0. And then bring down the 0. Okay, so this is 10.5. Okay, and then you gotta just solve for b, so you're gonna divide both sides by 4. So what's 10.5 divided by 4? So you need to know how to do this without a calculator. So the 10.5 goes inside, the 4 goes outside, and then as long as this number has no decimals, you're good. Just line this decimal up. So how many times does 4 go into 10? Twice, and you put the 2 right above the 10, so it's gonna be 10. 4 times 2 is 8. 10 minus 8 is 2, and then bring down the 5. How many times does 4 go in about 25? About 6. So 6 times 4 is 24. Now you can stop here because if you look at all the choices, there's only one that's like a 2.6. But you can continue if you want. 25 minus 24 is 1. Bring down the 0. How many times does 4 go into 10? Twice. So 4 times 2 is 8, and then 10 minus 8 is 2. Bring down the 0. How many times does 4 go into 25? So your answer is 2.625. Okay, so that's not too bad, right? So on this one, I just plugged it in. I didn't wait at the very end. I plugged in my values and then isolate B. Okay, let's continue on. Question two, if A, it's just like one, we have this, and then if A equals 3, B equals 2, what is the value of C? So we gotta isolate C. So what I would do first is just plug in your values, right? Plug in your values that they give you. So A is 3, B is 2, find C. So it's going to be A is 3, so it's 3 parentheses, 2 times A, which is 3, plus 2 times B, plus 3C, parentheses equals to 1.5. 1.5 times B, B is 2. Okay, so this is 3, and then what you got to do is clean this up. 2 times 3 is 6, plus 2 times 2 is 4, plus 3C equals to 1.5 times 2. 1.5 times 2, if you don't know how to do that, it's like this. 5 times 2 is 10, carry the 1. 1 times 2 is 2, plus 1, that's 3, and then count how many decimal places. There's a total of 1. So you move this 1 place. That's it. So this is really 3.0, or you could just say 3, right? Okay. Then before I FOIL out this 3, you can simplify the inner parentheses. Let's do that. So 6 plus 4 is 7, 8, 9, 10, plus 3C equals to 3. Then what I would do is FOIL out this 3. So this would be 3 times 10 is 30, and then 3 times 3C is 9C. What did I do? Okay, your goal is to solve for C. So then I'm going to subtract 30 from both sides. What is 3 minus 30? Negative 27. Divide this by 9. C equals to negative 3. Okay, next one. Okay, question 3. So consider A is equal 4 and B equals 1. We got to simplify this. So just be careful with the parentheses. You see there's a double parentheses here, so we got to be careful. Just try to stay neat. So A is 4 and B is 1. So it's going to be C times B. B is 1. Parentheses. A is 4 minus 4. And then parentheses followed by another parentheses plus A. Wait, A is 4. So you replace that with 4. And then his C is, we don't know what C is, plus B. B is 1. And then C minus 2. Okay. So the good news here, if you look at this part right here, 4 minus 4 is 0, and then you don't have to worry about anything else because 0 times anything is 0, right? So this just becomes canceled or 0. Over here, what I would do is first FOIL out the C plus 1 and the C minus 2. And unfortunately, there is no shortcut. You just gotta FOIL it out and just be careful. So C times C is C squared. C times negative 2 is negative 2C. 1 times C is C. 1 times negative 2 is negative 2. Then we're all going to multiply this by 4. Before I distribute this 4, let's see if we can simplify in the inner parentheses here. So you have C squared. Negative 2C plus 1C is negative C minus 2. There we go. And then lastly, FOIL out this 4. So 4 times C squared is 4C squared. 4 times negative C is negative 4C. 4 times negative 2 is negative 8. Okay, so that's your final answer. 4c squared minus 4c minus 8. Okay, next one. Let's move on to question 4. We have this linear line y equals 2x minus 6. Which of the following represents the same relationship of the given function? So on the first one, let's see. Let's look at our choices. We have a table. We have a linear line, and then C and D. Let's look at the table first. So let's see if this really does make sense. We have our equation y equals 2x minus 6. Let's plug in the x value -3. If it spits out -12, it works. Then try -2. If it spits out -10, it works. So let's first try -3. So it's 2 times -3 minus 6. 2 times -3 is -6 minus 6, which is -12. That looks good. Let's try -2. So it's 2 times -2 minus 6. 2 times -2 is -4 minus 6, which is 6, 7, 8, 9, 10, -10. Hello, that works. Let's try one more just to be safe. Y -1. So 2 times -1 minus 6. 2 times -1 is -2 minus 6, which is -8. Okay, so yeah, I think you could have just got away with it with if you plugged in 1 point, and if it comes out to that y value, I think you're fine. So this is the correct one. You don't have to look for the other ones, right? Because you remember you have a time limit, so yeah. Let's move on to question 5. Consider the graph, and it looks like a linear line. Um, what are they asking? You have this linear line, and which of the following option represents the same relationship as demonstrated in this graph? Um, Maybe we should find the equation of this line. So let's find that equation real quick. So as you can see, it goes through the origin, 0, 0. So that means we can use 0, 0. That also means our B value is 0, right? And then I'm going to pick a random exact point on this graph. So I'll use this point right here. And that random point is exactly at -4, +2, right? So what we want to do is put it in the equation y equals mx plus b. And we already know our b is 0 because that's our x-intercept, I mean our y-intercept. So all we got to do is find our slope. So how do we do that? Use the slope formula. So m is y2 minus y1 over x2 minus y1, x2 over x1. So y2 is 2 minus my y1 is 0. My x2 is -4 minus my x1 is 0. So 2 minus 0 is 2, and then -4 minus 0 is -4. Reduce. So that could be 1 over 2, -1/2. So my final equation is going to be y equals -1/2 x plus 0. Okay. So is it A? Well, I don't know because you kind of have to get y by itself. So what I would do is maybe subtract x, you get 1/2 y equals -x, and then get rid of this 1/2 by multiplying everything by 2. So that's going to be -2x. Okay, this is automatically no, right? This is our equation y equals -2x. This is -1/2 x. No. What about B? So they give us a table and we have our equation, right? Our equation was y equals negative 1/2 x plus 0. So what you got to do is just plug some points. If it gives you the y value, it works. So let's try plugging 4. Oops, positive 4. It's negative 1/2 times 4. What's negative 1/2 times 4? Negative 2. Wait, that means this is wrong because this is supposed to spit out negative 2. It gets spits out a positive 2. So no, not B. Is it C? So C says the graph has a positive slope and no, our slope is negative 1/2. So no. So it has to be D. D says none of the option demonstrates yes. So it has to be D. Correct. Question 6. Consider the following table which contains the values that are found on the graph of the function. Which of the following option is accurate given the aforementioned information? Information. So they give us like point or a table, and let's see what are the options. So let's review the options. So is it A, the function is definitely not a linear function? Let's see. So how do you know if it's a linear function? So that is a good question. So at first, because I already did this one, at first I thought they have to have a constant that's a constant that is always true. So for example, 16 to 18, you had to subtract 8. 8 to 4, it was minus 4. So that that gave me I assume these aren't the same, so it is you can't at first I thought it was not linear, but just because these aren't the same, it could be linear. So how do I know if it's really linear? So there's one more test you could do. If the slope is consistent. So what I mean is if you pick 4 points, so let's start with 2 points. So if I use 16, 9, and 8 comma 5, right? Let's find the slope of that. So this is x1, y1, x2, y2. So my slope is going to be 5 minus 9, x2 is 8 minus 16. So 5 minus 9 is 6, 7, 8, 9, negative 4. 8 minus 16 is negative 8. Two negatives becomes a positive, so 4 over 8. This could be reduced by 4, so that's 1 over 2. Okay, so that means if you pick another 2 points, and if the slope is 1/2, that means it's linear. If it's not, it's no longer linear. So it doesn't matter what. So if I use 4 comma 3 and 2 comma 2, right? Let's see. So it's y2, which is 2, minus y1 is 3, and then x2 is 2, minus x1 is 4. So 2 minus 3 is negative 1. 2 minus 4 is negative 2. Two negatives becomes a positive, so it's 1/2. Okay, so as you can see, the slopes are definitely the same. That means it's definitely linear. So it's not it is definitely linear. So don't be fooled. Just because you don't have a consistent difference, doesn't mean it's not linear. You can look at the slope. Is it B? The table displays values of linear functions. Function graph has a negative slope. Our slope was positive 1/2, so that's not true. Is it B? Um, let's see. So let's find the equation real quick. What is the equation? So I know our slope is 1/2. So it's gonna be 1/2 x. Do we have our B? Yes. Uh, your b is 1 because this is the same thing as a y-intercept. And how do I know it has an x value of 0? So my b is 1. So here's my equation. Now, is this the same as c? Let's see. Let's kind of like solve for y. So what I have to do is subtract 2, solve for y. So I'm going to add x. We get 2y equals to x minus 2. And then solve for y by dividing both sides by 2. That's 1 half x. Close, but not quite. This is a negative 1. Our b has to be positive 1. So that means our final answer has to be D. If you don't believe me, yeah, it's D because our slope is positive 1 and our slope is, I mean, my B is 1 and then my slope is 1 half. So if I pick this point, if I rise 1, run 2, yes, that's it. Perfect. Question 7. If AY plus X plus C equals 0, where A equals 0 and C equals 2, which of the following has the same relationship as the aforementioned information? So let's plug in our values. So they're saying that A equals 0 and C equals 2, so let's do that. So it's going to be 0 times Y plus X plus C, which is 2, equals 0. Is that true? So 0 times Y, that just cancels. So you're just left with X plus 2 equals 0. And then solve for X by subtracting 2. So you get X equals negative 2. Okay, so what is this? Is this a linear line? Yes. And how does that look like? So it's a vertical line. It's a vertical linear line, right? So it would look something like this. So if you have an X and then a constant, see how this doesn't have a letter? It's completely vertical. So that would look like it's negative 2. Do like a complete vertical line like that. Okay, is it the first one? No, this is horizontal. That would be y equals a constant, so that's not it. Is it this table? No, look, if you plug in, do you see the point 0, comma negative 2 on our graph? No. All the points are right here. Is it C? That looks good, right? Look at all the x values. That's true. All the values must be negative 2. At negative 2, yeah, that's a point. Negative 2, comma 3. Yep, yep. All these points are all in this graph. So definitely yes, yes. What about the last one? Um, no, even though, no, it's a horizontal line. It would be y equals a constant, so that's not it. So let's see. Okay, let's move on to question 8. What is the next number of the following series of numbers? So we're dealing with sequences. So when we're dealing with sequences, just note we can be arithmetic, meaning you have a common difference, and it also could be geometric. Common ratio, meaning you multiply a number. Sometimes it would be like neither, sometimes it would be a mixture of both. It can be quite, can be really what's the word? Like they can really be very sophisticated with these numbers. So question 8 says we have numbers negative 13, 18, 49, and 80. So let's start if we have a common difference. So negative 13 is like your first term, 18 is your second, third, and then your fourth, right? So from negative 13 to 18, would you have to add? 31. From 18 to 49, what did you have to add? 31. From 49 to 80, what did you have to add? 31. So it looks like we have a common difference of 31. So that means the next term or the fifth term, all you got to do is add 31. So what's 80 plus 31 without a calculator? It would be 111. So it would definitely be C. Okay, so that one's the easy one. Yeah, they can get a little bit really sophisticated sometimes. Let's try next one. Question 9. We have 15.5, 12, 8.5, 5, and 1.5. Let's start, let's see if we can find a common difference. So from 15.5 to 12, it looks like you had to subtract 3.5. From 12 to 8.5, it looks like you also had to subtract 3.5. From 8.5 to 5, it looks like you also had to subtract 3.5. And then 5 to 1.5, it looks like you have to subtract 3.5. Okay, so it looks like we're have a common difference of negative 3.5. So what you have to do is do 1.5 minus 3.5. So yeah, what is 1.5 minus 3.5? It is negative 2. Question 10, what is the number of the next following series? So here are my numbers 8, 11, 17, 26, and 38. So let's see if we can find a common difference. What do you have to add to get from 8 to 11? 3. What about from 11 to 17? What did you have to add? 6. From 17 to 26, what did you have to add? 9. And then from 26 to 38, what did you have to add? 12. So as you can see on the other ones, we are adding numbers, but they're not consistent. And the other ones we either had to it was always like the same number. But this one, what do you see? From 3 to 6, you had to add 3. From 6 to 3, you had to add 3. So you would have to add another 15, right? So just do 38 plus 15. That is 9, 10, 11, 12, 13. Carry the 1, that's 4, 5, 53. So that would be my next number, D. Okay. So yeah, these numbers, especially when you have a time limit, it can get really confusing. Let's try 11. So look at the numbers. We have 1/3, 3, 1, 3, 3, 9, 27. I don't think we'll add a number. I think we're going to multiply numbers. So from 1/3 to 3, what did you have to multiply? 9, right? And then from 3 to 1, what did you have to multiply? 1/3. And then from 1 to 3, what did you have to multiply? 3. And then from 3 to 3, what did you have to multiply? 1. And then from 3 to 9, you had to multiply by 3. And then from 9 to 27, you had to multiply by uh, 3. So as you can see, they're not consistent. This is like 9, 1/3, 3, 1, 3, 3. But do you see some kind of pattern? Yes. Notice that each difference matches the number in the previous series. So like see 1/3 matches with this number, 3 matches with 3, uh 1 matches 1, 3 and 3, 3 and 3. So what do you think the next one has to be? Yep, you said it. You have to multiply by 9 because this number is 9. So you're gonna have to multiply 27 by 9 and you get 243. Yeah, so that one's a little bit tricky. Okay, next one. So 12. We have 8, 4, 6, 3, 4.5. Which of the next numbers in the following series are which is an which is the next number in the following series of numbers? So 12. Okay, so let's see if we can find a common difference. From 8 to 4, I think you would have to subtract 4. From 4 to 6, you had to add 2. From 6 to 3, you had to subtract 3. From 3 to 4.5, it looks like you had to add 1.5. Obviously, they're not the same. I don't see a pattern. Like 2, remember the other ones, 2 matches with 8. I don't see that. So what about let's find a common ratio or a number that multiplies. So from 8 to 4, what did you have to multiply to get from 8 to 4? Uh, 1/2. From 4 to 6, what did you have to multiply? 1.5 or 1.5. From 6 to 3, what did you have to multiply? Uh, 1/2. From 3 to 4.5, what did you have to multiply? 1.5. So I see a pattern. It went from 1/2 to 1.5, 1/2, 1.5. So the next number you have to multiply is 1/2, right? So what's 4.5 times it by 1/2? The 1/2 is the same thing as 0.5. So that would be 5 times 5 is 25. Carry the 1, 2. 5 times 4 is 20. Carry the 2, 22. 0. 0 times 5 is 0. 0 times 4 is 0. 5, 2, 2. Count how many decimals is 1, 2. It's 1, 2. So it's D, 2.25. Yep. And that was, as so you can see, that was a little trickier one. Okay, let's move on to question 13. Simplify the polynomials to the simplest form. Um, just FOIL it out and collect like terms and then go from highest power to lowest. So there's really no trick. Just FOIL out, be careful, collect like terms. So what I would always do is in the parentheses, always make sure if you can combine like terms before you FOIL out. So this one, no, this is a 4x, 2x, 3x minus 2x, no, there isn't. So you're just gonna have to FOIL it out and be careful. So let's start here. What's 4x cubed times 3x? Well, 4 times 3 is 12. And then you have x4, right? because x cubed times x1. So you're multiplying the letter and the constant. So that's going to be, yeah, 12x fourth. And then what's 4 times, I mean, 4x cubed times negative 2x fourth. That would be negative 8x to the 7th. And then 2x times 3x is positive 6x squared. And then what's 2x times negative 2x fourth? That is negative 4x 5. Okay. And then go ahead and FOIL this out. So x squared times 9 is 9x squared. X squared times negative x squared is negative x squared. 7x times 9 is 63x. And then 7x times negative x squared is negative 7x cubed. Okay, and then just go from highest power to lowest. So my highest power, it looks like, starts with 7. I don't see any other 7, so negative x7. The next one is 5. Let's see. I see a 5 here, so it's going to be negative 4x5. The next one is 4. I see a 12x fourth and negative x fourth. That is 11x fourth. Next one is 3. I see negative 7x cubed. The next one is x squared. Uh, so you have a 6x squared and a 9x squared. That's 15x squared. And then the next one is 63x. It looks like your answer is B. Okay. So it's just simple foiling and collecting like terms. That's it. Consider the following, which of the following form is equivalent to this. So just FOIL it out and collect like terms. So what I would do first is I would not FOIL out this x squared first. What I would just FOIL out these first and then FOIL out the x squared. So what's x squared times 7x cubed? That is 7x5. What's x squared times 1 x squared? What's 3x times 7x cubed? That is 21x4. What's 3x times 1? 3x. And maybe we should just put that in order. So 7x5 plus 21x fourth, and then plus x squared is 3x. Okay, then I will FOIL out that x squared. That's going to be 7x squared times x5 is x7 plus 21x6 plus x4 plus 3x cubed. So that looks like it's going to be letter D. Okay, let's move on to question 15. So factor the polynomial. So if you forget all your factoring rules, that's perfectly fine. Just scroll down to the supplementary videos, and there's like a section that's all about factoring. So in this one, we have 3x squared minus 7x minus 20. There's a specific factoring method you'll use. This one's called, I call it bottoms up factoring. And why do we use bottoms up factoring for this one? Because the A is no longer 1, our A is 3. So what's the first step? So first step is you're going to rewrite it. You're going to rewrite this problem. You're going to rewrite it as if 3 does not exist, and then the last term will no longer be negative 20. It would be 3 times negative 20. So what I mean is it's going to be expressed as x squared. Negative 7x stay the same. And then the last term does not. It's basically 3 times negative 20, which is negative 60, right? Okay. And then from here, we could just do regular simple factoring. An x here, an x there, and then blank space, and then blank space. So can you come up with two numbers and then multiply negative 60, and when added gives you negative 7? Believe it or not, it's actually negative 12 and 5, right? Right? Negative 12 times 5 is negative 60. Negative 12 plus 5 is negative 7. Okay. Then what we do is remember the 3 here. So you're only going to divide the negative 12 by 3 and divide this 5 by 3. Okay, so what's negative 12 divided by 3 is negative 4. 5/3 is a fraction that can't be reduced, so you put the 3 in front of the x, so that's going to be 3x plus 5. Okay, so my final answer is x minus 4 times 3x plus 5. So letter D. Okay, question 16, factor the polynomial using the greatest common factor. So if you forgot how to do factor using greatest common factor, there is a section on supplementary factoring GCF. So how we do this is it's not as bad as it looks. Figure out how many terms we have. We have, believe it or not, we only have 3 terms. This whole thing is one term, this whole thing is one term, and then this whole thing is one term, right? Okay. Once you figure out how many terms you have, then let's figure out what we can take out. So I always start with my letters, and I'm going to start with my letter Z. So over here we have 3z's or z cubed. Over here we have 4z or z4, and over here we have 5z or z5. What is the largest amount of z's we can take out evenly? Yes, we could take out 3z's or z cubed, right? Evenly, right? Because this has 3, this has 4, this has 5, so the largest amount of z's we can take out evenly is z's. Okay, what about the y's? We have a y7, a y5, and a y cubed. What is the largest amount of y's we can take out evenly? Right, y cubed. And then what about our constant? We have a 6, a negative 12, and a 3. What is the largest number that they're all divisible by? Between 6, negative 12, and 3. What is the largest number that they're all divisible by? 3, right? They're all divisible by 3, and you can't go any higher. Okay, so this right here is my GCF. Now we can't change our problem, so let's go back to the first term, this one right here. What do we have to multiply 3y cubed z cubed to get the first term 6y 7 z cubed? We're going to need a 2. And then how many y's? Well, we already have 3, so how much y's we need? We're going to need 4, right? And then what about the z's? Yeah, we don't need any more z's because we have z cubed, so we're good. And then look at the second term. What do we have to multiply 3y cubed z cubed to get the negative 12? Y5 z4. So we're going to need a negative 4. And then we're going to need a y2. And then we're going to need one more z. That's it. Now look at the third term. What do we have to multiply? We're going to need, we don't need any 3's. We don't need any y's, but we do need some z's. So I'm going to put a plus z and then how much? Z2, right? Because we'll remember when you multiply, you add. So 3 plus 2 is 5. So that's my answer, and that would be letter A. Okay. Question 17. Which of the graphs accurately portrays the following two linear equations? So we're dealing with system equation, and I do not recommend graphing these two linear lines individually. What instead I would do is find the point of intersection or the solution. So how do we do that? We have this linear line 2x plus y equals 5, and then y equals 3 minus x. So we're dealing with system equation. The method so we're trying to find where they intersect. So it's like an x comma y coordinate. So what method shall I use? I'm going to use substitution. And if you forgot how to do these, there is a video on supplementary videos on system equation, and it'll explain how. But I'm going to do substitution because I have one of my letters, and this one, the first, I'll call this the first equation and then the second one. So what I'm going to do is substitute equation 2 back into equation 1. What I'm going to do is use this, plug that back into here. So what that means is it's going to be 2x plus y, and then y is 3 minus x equals 5. Okay, and then simplify 2x, and then negative x is x plus 3 equals 5, and then solve for x by subtracting 3. So 5 minus 3 is 2. Okay, so my x coordinate is 2. Now, how do you find my y? Easy. To find the y, you simply plug in x equals 2 back into the second one. You could plug in the first one, but that's just more work. So I'm going to plug it in the second one. So it's going to be y equals 3 and minus x, and my x is 2. So 3 minus 2 is 1. So my system equation is going to be 2 comma 1. Which one is that? Looks like it's this one. See, this has a solution. See how where they intersect at 2 comma 1? That's the one. Okay. Next one. Question 18. So this one, consider the following formula. We have q over 4 equals p over 6 minus 0.5. Which of the following statement is true for this formula? So this is literally like a linear equation problem. And I would not okay, so when you're doing these linear equations, sometimes you have to graph it, and sometimes you can just get away with it by plugging in values. This one, you can't just plug in value and figure out which is correct, because sometimes it can be always true. This one, you kind of have to like graph it. So when we're graphing a linear equation, we got to figure out what's our x and our y. So we could get rid of the fraction by multiplying by the LCD, but we don't have to. And you don't have to do that on the exam because I know you have a time limit. So we got to figure out my x and y. So what do you think my x and my y is? I think our x is going to be our q, and I think our y is going to be our p. Why? Because it's the cause. This is your cause, and then this is your effect. Okay. So my p is the y, and my x is my q. Okay. So that's the first step. Then what we got to do is graph it. So I'm going to graph this by finding the y-intercept and the x-intercept because we have like these fractions. So yeah, let's do that. So let's start with the y-intercept. Do you recall how to find the y-intercept for any graph? Yes. You simply plug in 0 for x and then solve for y. So our x is q. So we're in our case, so wherever you see net q, plug in 0. So 0 over 4 equals to p over 6 minus 0.5. And then you're going to solve for p. So over here, what's 0 divided by 4? 0 minus 0.5. And then you're going to solve for p. by adding 0.5 to both sides. 0.5 equals p over 6. And then solve for p, so I would just multiply both sides by 6. So what's 6 times 0.5 or 0.5 times 6? You can do that, right? 6 times 5 is 30. Carry the 3. 0 times 6 is 0. And add 3. This is a total of one decimal. So my p is 3. So we have a y-intercept at 0, 3. And then let's find our x-intercept. So my x-intercept, how do you find the x-intercept? You simply plug in 0 for y. So what is my y? It's my p. So go back to here, replace p with 0. So it's q over 4 equals 0 over 6 minus 0.5. So it's q over 4. 0 over 6 is 0, so it's 0 minus 0.5. So you get q over 4 equals to 0 minus 0.5 is negative 0.5. Cross multiply, so it's q, and then it was 4 times negative 0.5. 0.5 is the same thing as 1/2, so it's like negative 2. Okay, so we have an x-intercept at negative 2, 0. Okay, let's draw our Cartesian plane, and you'll see why we graphed it. You'll see why we did this method. Okay, so let's see. Oh, we said that our x was our q, and our y is our p. Okay, so my y-intercept is 0, 3. Here's 3. My x-intercept was, what was it? Negative 2, 0. Okay, connect the dots. Okay, now let's just test each one. So um, if p is less than 6, so p is the y-axis, right? Here's p. If p is less than 6, so that means like 5. Wait, so here's 3, 4, 5, 6. Here's 6, and then that means less than 6, so like 5. The q is positive. That is sometimes true because 5, your q is positive. 4, positive. 3, positive. But once you get below 3, like 2, the q becomes negative. So that's why it's not always true. What about b? If p is less than 3, so p is the y-axis. If it's less than 3, so that means 2 and below, q is positive. No. So if you look at the 2, what's my q? It's negative 1. My q is negative, right? And beyond. So it's not b. What about c? Okay. C says if p is less than 6, so here's 6, less than 6. Q is negative. No, it could, yeah, it is negative a bit, but it's also positive as well, because if you look at 5, the Q is positive, so that's not always true. What about D? If P is greater than 6, so like anything beyond 6, whoops, like 7, the Q is going to be positive. Yes. 8, positive. 9, positive. Yes. Even when you go higher above, the Q will always be positive. So it has to be D. Okay. So on this one, this is a linear line. We did have to graph it, right? I don't think plugging a value would always work. Okay, let's move on to question 19. Let's say we had 2 over x equals 3 over y. What, which of the following statements is always true? Um, this one I would definitely try graphing. This one is actually given. Your y is your y, your x is your x, right? We don't have to figure out. Yeah. So we have 2 over x equals 3 over y. So what you want to do is solve for y so you can cross multiply. So this is going to be 2y equals to 3x. And then solve for y by dividing both sides by 2. So y equals 3 half x. This one, you can graph this, right? It's pretty simple. Our x is our x and our y is our y. So here my b is 0, so you could put like a 0 here. And my slope is 3 halves, so what you could do is go up 3, 1, 2, 3, and then run 2. So it would look something like this. Okay, so let's look at our choices. Part A, when x is positive, x is greater than y. Actually, this one, maybe we could just plug in values. So let's look at this one. When x is positive, so that means like 1, 2, 3, 4, and beyond. So let's try x equals 1. So y equals 3 half times 1. Uh, 3 half times 1 is 3 halves. So when x is positive, x is greater. Not in this case. X is 1 and our y is 3. So that's false, right? That's false. What about B? When x is negative, y is less than. So let's try x equals -2. So it's going to be y equals 3 halves, and then x is -2. I could have used -1, but you'll see why I stick with -2 because I don't want to deal with decimals. So what's 3 half times -2? It would be -3. Okay. So is this true? When x is negative, y is less than x. So here we chose x equals -2. When we plug that in, our y value is -3. So it's true. When x is negative, y is less than x. Yes. When we plug in x for -2, it spits out -3, which is this. So it's definitely B. Question 20. Consider the following formula: G over 3 equals H over 4. Which of the following statement is true for this formula? So this one, I would not graph this one. Um, what I would do is, so if you look at the question A, yeah, question A, the difference between the values of H and G are constant. I think I would get G by itself. So we have g over 3 equals h over 4. And to get g by itself, I can cross multiply, so this is going to be 4g equals to 3h. And then you're going to solve for g by dividing both sides by 4. So g equals to 3/4 h. So let's look at the first part, the difference between the values of h and g. So let's just say, yeah, this is going to be h minus g, and g is 3/4 h. So 1h minus 3/4 is 1/4 h. That's not true. This is not a constant, right? 1/4 h is not a constant. You have a variable. If it was just 1/4, then yes, that would be constant. What about the second one? The difference between the values of h and g, the difference between the values of h and g diminishes for greater positive values of h. I don't think that's true either. No. Okay, what about C? For positive values, the difference between the difference between g and 0 is less than the difference between h and 0. I think that's true because it would be for the positive values, the difference between g and 0. So it's like saying g minus 0 is less than h minus 0. G minus 0 is g, h minus 0 is h. And then g is 3/4 h, so it's 3/4 h is less than h. That is definitely true, right? 3/4 h is less than 1h, yes. So it's going to be C. Okay, next one. Let's do 21. Consider the following formula: 3e plus d minus 5 equals 2d minus 5d plus g. Which of the following is true for the formula e values greater than 1, e is greater than 1? Oh, okay. So this is pretty right? So what I would do is solve for d and then graph it. Yeah, this is a linear line, and uh I would solve for d. That's our d's are y. Yes, our d's are y, and our e is our x. Okay, so let's solve for d. So over here we can simplify the right side. What's 2d minus 5d? Negative 3d. And then you have 3e plus d minus 5. And our goal is to solve for d, so I'm going to add 5. You get 3e plus d equals to negative 3d. And then 11 plus 5 is 16. Okay, continue solving for d, so then I would add 3d to both sides. You get 3e 1D plus 1D plus 3D is 4D, 16, and then solve for D. So I'm going to subtract 3E. I get 4D equals to negative 3E plus 16. And then divide everything by 4, 4, and 4. So D is equal to negative 3/4 E. And then 16 divided by 4 is 4. Okay, so now we can graph it. So our D is our Y and E is our X. So how would we graph it? Let's find, so my y-intercept is your B. We have a y-intercept at 0, 4. And then to find the x-intercept, you plug in 0 for D, so that's going to be 0 equals negative 3/4 E plus 4. And then I'm going to subtract 4 from both sides. So negative 4 equals negative 3/4 E. And then you can get rid of the fraction by multiplying both sides by 4. So 4 times negative 4 is negative 16. The 4's cancels, you're left with negative 3E. Divide this by negative 3, divide this by negative 3. Uh, that's about 5.3. So you have a x-intercept at 5.3. So if you graph it on a Cartesian plane, let's see, x is, what is it, 5.3? Right here. And then my y-intercept is 4. So let's look. Okay. Now, so my x is my E, and then my y is my D. Okay. Is letter A true? Is D greater than E? No. Look, here's D. It's obviously not greater than E. What about D? Does D equal to E? That's something. That's a big no, right? Um, look at our equation. If you plug in D for 0, you have this plus 4, so it's never going to equal to 0, right? So it's not that one. Is it C? Is D less than E? No. So that means our final answer has to be D. Okay. Okay. Next one, 22. This one, negative x plus 3 equals negative y. I would just graph it. Really simple. The y is the y, the x is the x. So all I got to do to get y by itself is get rid of this minus by dividing everything by negative 1. So you get y equals to x minus 3. And my y-intercept is 0, negative 3. And then my x-intercept is, replace y with 0, so that's going to be 0 equals to x minus 3. Add 3 to both sides, x equals 3, or 3, 0. Okay, so when I graph this, okay, so this is going to be 3, comma 0. And then what's our y-intercept 0, comma negative 3? Connect the dots. And yeah, there's our graph. So let's test each one. If x is greater than negative 3, is y negative? So here's locate where negative 3 is. 1, 2, here's negative 3. Greater than. So it could be x is greater than negative 3, it's negative. So it might be partially true. So if you did negative 3, the y is negative. If you did negative 2, the y is negative. If you do negative 1, the y is negative. But if you plug in 0, uh, it's still negative. But when you plug in 1, that's when it starts to get positive because it says greater than equal to. So that's not always true. What about B? Uh, if x is greater than 3, greater than equal to 3, then y is negative. So locate where 3 is. So if 3, the y is positive. 4, the y is positive. 5, the y is positive. It's always going to be positive no matter what. See? If x is less than equal to 0, y is negative. So locate where 0 is. When you plug in 0, the y is negative 3. When you plug in negative 1, the y is negative. When you plug in negative 2, yes, that's always going to be true, right? So it has to be C. 23, 9a equals 2b minus 4. Which of the following statements are true for this formula? Yeah, you're just going to have to graph this one. And I think, I believe our a is going to be our x, and my b is going to be my y. So our y-intercept is 40. Wait a minute. So yeah, my a is my x and my b is my y. My b is my y. So actually, yeah, let's find our x-intercept. So x-intercept, how do you find the x-intercept? You simply plug in 0 for y, in our case, b minus 45. So this is going to be 9a to negative 45. Divide this by 9. A equals to negative 45 over 9 is negative 5. Okay, so that's my x-intercept, negative 5, comma 0. And then how do you find the y-intercept? Um, to find the y-intercept, you plug in 0 for x. In our case, is it a? And to save you time, that's going to give you 0, comma 22.5. Okay, so when you graph it, it gives you, so here's, and my y is 22.5, so let's go by 5s, 10, 15, 25. Right, so which of the following statement is true for this formula? Um, let's see. Let's look at A. When the value of A, so what is A? Our A is X. So when the value of A is less than 5, so that means like here's 1, 2, 4, 5. So less than 5, so like 4, um, and below. So is it positive? It is sometimes true. So like here's 4, the y is positive, 1 it's positive, but when you get to negative, or below 5, -5, it starts to become negative. So that's not always true. What about B? When the value of A is greater than -5, B is positive. When the value of A is greater than -5, so here's -5, um, is the Y value positive? Yes. For example, here's -4. The Y value is positive, positive, right? So this is always true. You want to pick the one that's always true. Okay, right. Okay, so something different now. So 24, solve for the proportion x. And they don't give us any input value, so you just gotta solve for x. So I notice I only have two sides, the left and the right. So what you can do if you only have two sides, you can cross multiply. So that's what I'm gonna do. I'm gonna cross multiply. So it's gonna be 7 times x plus 6 equals, then cross multiply. So it's a minus 2 times 42 minus 3x. Okay. So when you simplify, okay, so over here, what I'm going to do is FOIL out this 7. So that's going to be 7x, and then 7 times 6 is 42 equals, and over here, when you FOIL this out, this is going to be 42a minus 84 minus 3ax plus 6x. My pencil is like dying, like kind of dying. So, wow, this video must be at least kind of long, so. Okay, then what I'm going to do is, my goal is to solve for x. Any anywhere there's an x, get it on one side. So let's subtract 6x from both sides. So 7x minus 6x is x plus 42 equals to, over here, this is going to be 42a Okay, so now what I will do next is get rid of this 42, move it to the right because it doesn't have an x, and then move this negative 3ax so to the left because it has an x. So I'm going to add 3ax, and then subtract 42, and you get x plus 3ax. Okay, and then on the left side, notice that they have an x, both have an x. That's good. So you're going to factor out an x, and this is going to be 1 plus 3a equals 42 minus 126. And then to solve for x, I'm going to divide both sides by 1 plus 3a, 1 plus 3a. And I get the first one. Okay. So I'm going to stop here because my pencil is dying. So I'll finish the other ones in part two. Okay, so let me stop. Let me put a circle in 24. Yeah, 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 we can stop on, or yeah, we'll do the others on another day. I'm gonna stop here.